So just in terms of, right here, currently we're storing the CSV data locally on our machine, but really, and we'll get into this when we get into AWS, you can pretty easily write this data to an S3 bucket in AWS. What's S3? S3, you can think of S3 as like Dropbox. Okay, it's just a folder on the cloud for you to store files in any kind of files. It could be images. It can be, you can literally like just take a folder from your computer and upload it onto S3. A difference from Dropbox is, well, this has like an easier API where we can use Python to the same way we do the same way that we do like 2CSV. We can do something very similar. In fact, I might deploy these lessons as bonus, showing you how, where you can just write to an S3 bucket, like basically to the cloud, very easily. Alternative, so this is AWS's provider, or AWS's what's called like blob storage, kind of meaning like that you can store anything there. Google has an equivalent, right, which is like their bucket as well. They also have like blob storage. So, and I'm sure Microsoft does as well. I'm not as familiar with Azure, but basically each cloud provider will have their own format where you can store just files, essentially like any kind of files. Yeah, how is it? Okay, cool. So we're getting multiple questions. So one is, how is S3 different from Dropbox, Google Drive? It's not really like I mean, I'm sure that there are different things. So is it different versus Dropbox, Google Drive? So one is like easier API. Another thing is like security. Like you can manage fine-grained security, meaning you can say, hey, I only want these people in my organization, right, inside my company, being able to access this file. Or you can say, I want basically anyone being able to access this file, right? Meaning like the broader public. So though, I'm sure Dropbox like has security, but this is like pretty fine grained as to, oh, and then by the way, I only want read access and not write access. And all of that can be managed from an API. So that's a second thing. Another benefit of it is just like essentially like latency, like how fast, say we're serving these files to people around the world. Say this is like hosting images for a website. S3 will, in terms of how it stores or if it makes copies of them, will make it faster to access the files if that's kind of an issue. It's been a while. Like you can go on AWS's site and it will tell you things about S3, it tell you the various features, but these are some of the things that I remember. Oh, that's a good point, right? And then that's a very good point, Miles. So Miles says, well, the other thing is, right, we can have S3 talk to the other AWS services, and that's very true, right? Like we just talked about the fact that we're going to take the CSV data and load it into Postgres. As we'll see, later in the course, we'll take the CSV data, which lives on S3, and load it into a Postgres machine, which lives on AWS as well. So it's like our CSV data lives on AWS, and our Postgres, when we migrate it, this also lives on AWS, and we have to give permissions. You'll see that like a big part of AWS is just permissions, and we have to say, hey, this database has permission to access these files, right? And giving those permissions as well, right? Like that, these things can just speak together more easily, right? And it's not just, as Miles is saying, it's not just, this database. There's other kinds of, say we want a computer, like EC2 machine, being able to access it, that too. It's not worth me going, it's probably not the best time for me to go too deep into this now because we haven't gotten into AWS yet, but those are just some of the benefits. Let me see. No, I mean, latency factor only be significant when the code for reading and writing to S3 is also running in the same cloud. No, like by latency, what I mean is, let's say like different users around the world, like maybe this is client facing some of this data, and you need to be able to access it quickly from different locations. Here, it only, the way that Amazon does that underneath can be fancy, right? Like they can literally store it in different, like one in Virginia and one in San Francisco and one in Tokyo, right? Like there are things like that that it can do to make sure that it's fast regardless of where you are on the planet, right? So yeah, let's not go too deep into that. Then the other question though was like, how does the S3 or blob storage connect to a data lake? And the truth is that that's a really good question, because you would call this structure, if you're another way of calling this would be like, this is essentially your data lake, and now this part right here is what we're moving into eventually is like your data warehouse. Okay, so all the benefits, right, that we were talking about of storing something in S3, that is the reason for using a data lake as well, right? One, we get to store the raw data. We're not sure exactly how much value this data has, but we just want to hold on to it, so it's more cheap. It's cheaply. We can do it. We don't have to format the data, so we can always lose something when we format the data. So these are all benefits of a data lake. S3 data lake is an architecture, like MVC is an architecture. S3 is just the name of Amazon's service, Amazon's technology for kind of structuring a data lake. We don't need, however, again, it's just a tool can be using for a data lake, which is effectively what we're doing now. But you can use S3 for anything. Like I said, you can kind of think of it like Dropbox in a lot of ways. Okay. Yeah, like you don't have to store, like I'm storing, like I like stored some images on S3, just because, and had the curriculum read from there, like I started at a certain point in time. Like you can store anything on S3, but a common use case for data engineers is to treat it as a data lake, and that's essentially what we're mimicking when we store our CSV files. All right. And what is a data lake, right? Again, it's like kind of this low cost way to store like as much data as we want effectively, because it's low cost, and not need to really do any pre-processing on the data. So we don't have to worry about losing information as we change the data. So we can go back to the original source lots of times in a data lake, right? And we can store data that we may think we're never going to need this, but we can store it there just in case. Cool. The data warehouse, this is more expensive. As we'll see, it depends on which kind of technology we use. There are different versions of theirs. There's Snowflake, there's Redshift, which is AWS's. There's I don't know. You can think of Spark almost. But these are the two that mainly, there's BigQuery. These are more expensive. Redshift is very expensive. Snowflake is not as expensive, but can be really add up. So that's why storing data in here can sometimes really not be cost effective. But we'll get into that. All right. Okay, let's try to get into scheduling. So essentially where we are is, this is kind of our flow, right? Essentially what we just showed in the diagram, right? Find the receipts, meaning hit the API, then probably coerce the data. Maybe I'm not doing that in this lesson, but we would imagine coercing the data and storing it in a CSV and then loading it to Postgres. Now, here I'm just to make it simple, I'm just basically finding the receipts. If, again, one of the benefits of Prefect is the ability to automate this thing. So currently, the way that we saw of kicking off a flow is just to simply call the method, okay? So you just call, we're right here, right? So this is my file, and I just run python3 index.py, and that should run my flow. So it runs my flow, and then the flow runs the task, okay? However, as we said, like let's say like every month or every day, we want to get new receipt information and call the API and store it, in CS3 or my database, etc. What we want to do, of course, is like schedule it. To do that, and I don't love the names, the terminology that Prefect uses, but it uses what's called a deployment. So you create a deployment, and then each run of a deployment is called, and then is like you'll schedule what's called a deployment run. Okay, the way that you can think of it, like the way that I kind of think of it, is a deployment is kind of like a launch plan. Launch plan. The key word being the plan, right? This is like the blueprint, or like I said, I think the launch plan is fine, and then this is like each launch of in the launch plan. So you can see the way that we'll do this is we no longer want to kick off our flow, meaning like execute the function when we just run the file. Instead, what we'll do is we can do this one by one. Let me comment this out for now. You call the name of the flow. So it'll be get restaurants. That's the name of my flow. Notice there's no parentheses here, right? Dot serve, and then you name the deployment. All right. So this will create a deployment. Meaning it'll like create kind of like a launch plan. So now we can run this again. And notice nothing's being actually run right now, okay? Instead, it says it's being served and polling for scheduled runs, meaning that like essentially Prefect ideally will look to see, is it time to kick this thing off? And it says if you want, you can trigger, by hand, or sort of like manually trigger this by trigger the deployment by doing Prefect deployment run. Okay, so again, like right now, all we did was we kind of created the launch plan, which is to run my flow at some point in time, and we have not yet done any like deployment run. If we want to, we can go to a different tab and probably do this, and then it should. It broke. It might be. I do have the same environment, I think. Anyway, so this should in theory work. Let me try to do it a different way, and this is the way you'll do it in real life, which is, there's a couple things. Let me see. Maybe I know this error message. No, it's one of these weird ones. Okay. So there's two things that we need to do. One is, remember, we're going to call this method. If you call the method takes an argument, right? And the argument that it takes is the name of the restaurant that we want to like get our receipts about. So the first thing we need to do is specify the parameters to the method. Your method may not take parameters, in which case you don't need this argument, but ours does. Okay, so we'll need to do this, parameters equals, and now why am I doing URL? Well, that's the name here, and this is just an example of what I want to pass through. So remember, this thing's going to be running like overnight or something like that. When it's run, we're saying, hey, when you run this function, please pass through these parameters. The other thing we can do is an interval schedule. And what we're saying is, how often do I want you to run the function? Okay, there are various ways of specifying this, meaning like, specifying how long to do in between. What I'm doing right here is just number of seconds. So interval is 100 seconds. We can change it. We can do like 20. And just to point out, this interval schedule, this comes from this line of code right here. So basically, we're saying hey, I want to create a deployment called get restaurants deployment, run it every 20 seconds and pass through this string to the function and call it. If you had a default value for the argument, then parameters could be optional, could override it. I think that's true. I haven't tried it with a default argument, like putting a default argument to the flow and then passing through something. But in theory, that seems like it works. All right, let's see. I think this might be better. Let's find out. So now I'll run this. Being served, scheduled for runs. The other thing we're going to have to do is actually, and we can go into, this might be a little confusing, but you have to specify, I don't think this is actually going to start executing. Like, we can wait 20 seconds, but I don't believe we're going to see anything, run. The reason why is you have to run this line, which is start an agent pool. Okay, let's just start this up, and then we can explain what this does in a little while. Prefect. And I'm going to do prefect server start so we can start to view this thing. Okay, so oh man, so it's really just this environment source. I think I have to do deactivate. Yeah, and now I think it's just my my Python environment's not the same. Python 3 vim bin activate. That's so weird. Oh, source. I'm sorry. And now let's see if I source better. So that's the server. This is the agent pool. Okay, cool. So let's take a look. We can go to this deployments, and you see this is exactly what we created, right? Get restaurants deployment. I think I originally created a little while ago, but you can see it's every 20 seconds, and that's something that I recently changed. All right, so just to prove that this is kind of like triggering, let's try to change this to every 30 seconds, and then we can shut this down. The other thing you can see is this is starting to actually work. Let's just show one thing at a time now. So I do Python 3 index.py, right? I change the interval to 30 seconds. Let's refresh this. You see that? And this is getting updated with every 30 seconds. All right, the other thing you can see, I have this on green, right? This way it's going to continue to run. If you pause it, meaning you just click this button, right, it will pause. Once you click on, or this is essentially like the launch plan. If we click on the launch plan, we should be able to see then the actual runs, meaning like the deployment runs. So you can see that these are scheduled for every, 20 seconds. This was the most recent occurrence. So this was the Silky Turtle one, and that was running. It's probably what I forget if I. Yeah, you can. Oh, here it goes. So then here's Silky Turtle, right? So this is the one thing that ran, right? Completed this one, processed the flow for Silky Turtle. That was this thing that occurred right here. And then you can click on this actual run and view what occurred, meaning like see the tasks and view those logs. All right. Then, of course, go back, go to the flow runs, and see the next one. So the next one that just ran, because it's every 30 seconds now, is this resourceful walrus. So that thing just ran, and you can see that we logged it. So what did we need to do, just to review? First thing we had to do was reference our flow, get restaurants, and to create this deployment, meaning like the plan, we did .serve, specify the name of the deployment, get restaurants deployment. So that's right here, right? We have to say what parameters we want to pass through. Okay, and then like need it, ideally it kind of makes sense. The whole point of this is to schedule it, so you should pass through a schedule or specify a schedule. For the interval schedule, we're just importing that from here, right? This is just a prefect thing, and then we can ask, specify how many seconds in between each run. From there, I think the main thing that left to cover is we needed to, for whatever reason, this still is working. It's just this is the dashboard. But the main thing we needed to do was this prefect agent start a default agent pool. Okay? So this is the next thing that we should talk about. Let me just pause. It seems like there are a few questions. If we want to call an API every hour to store data in a database, we can use this deployment and scheduling to run that process automatically. That's correct, right? So if you want to, call this API, or call an API every hour, every week, you can specify, you can have that occur. The annoying thing, right, what you'll need to do is you'll have to have this running in the background of your machine and have your computer like open, like your laptop on and open. That's why you wouldn't really do this on your personal laptop, right? We would deploy this on an AWS computer. So, like I said, we just I wanted to show you all this before we spent time getting into AWS. But yeah, like if you have your laptop running and you have this line running and you don't stop either of them, this will run, however often you specify it to. Yeah, so that's what Chris is asking. Will the scheduler work only if you have Prefect active in your computer? You need to have this thing active in your computer. You don't need to have the server, like the dashboard running. So I can stop this. This is just a way for me to like view it. But you will need to have this agent pool running, and also that you specify to like activate or schedule the deployment. So these two tabs you'll need running. When are the same thing? Okay, yeah, exactly. So you do need to have your computer on, and you need to have this running, and you need to have this agent pool. So now let's talk about the agent pool stuff. Okay, so this is how Prefect works. Is that, remember we had a deployment, and then we have deployment runs. These deployment runs are scheduled in advance. You can actually see that here. You see this is like scheduled in advance, and you can, if I click on upcoming, I guess there's none, but sometimes you'll see, even more. I forget if I shut down my server. Oh, I did. That's probably why. But there can be multiple things that are like 10 of these things, or a lot of them, scheduled, right, every 30 seconds for like all time, unless you specify otherwise. So then we have these runs that are scheduled in advance. Those runs are placed into a queue. A queue is just a collection of work to be done, all right? So this is a scheduled run, this is a scheduled run, right? These are all deployment runs that are scheduled to run. This is just the work that needs to be done, okay? This is like a set of instructions that needs to occur. But this is not anyone actually doing the work or assigning the work to anyone. Instead, what you have is we have workers. Think of these as little minion dudes, right? This guy is a worker, this is a worker, this is a worker, this is a worker. They're just waiting, okay? And that's what we did when we did this line, default Prefect agent start, a default agent pool. What we're doing is we're creating a work pool that has workers in it. At the time, what will occur is Prefect will start polling, meaning it'll look to see, is there any work to be done? If it finds work to be done, meaning like the 30 seconds is up, it will assign the scheduled run, the work to be done, to a worker in the pool. And then that worker will begin executing the process, right? Meaning it will begin executing your workflow, and the tasks involved. So that's why you have to have this thing running. If you don't have this running, It's not like there's no program running that's going to actually do the work, run the program. Okay, when it's done, right, it finishes, it completes it, and then it's logged, and then this guy goes back into the pool. Okay, you can have more than one worker because sometimes these tasks can run concurrent, like at the same time, and you can see that. Let's see, I think it even. You can see that somewhere too, like a specification as to whether or not is it okay to run this concurrently. I don't see it right now, but that's kind of the idea in terms of what these workers are. It's a little out of order, but they're essentially threads in your computer. Everything, whenever you run anything, you're assigning like CPU. So you basically have, let's say you have a CPU, okay, and then each CPU, right? This is the processing unit, right? This is the actual hardware. This CPU has a certain amount of threads that it can run. So when you're running, Python, when you do like Python 3, index.py, it's going to allocate, and you're like executing Python, it's going to allocate, a thread, meaning like a processing power or a thread to execute the code. Okay. Now, one CPU can use multiple at the same time. Generally, what's the limit is what's called like cores in a CPU. So let's say your one CPU has like 16 cores in it. You can allocate, let's say you might allocate, if you want to allocate in our work pool, you want to allocate 4 different cores, then you can have, 4 threads running at exactly the same time. Like let's say you want to call, 4 different flows at exactly the same time, you can do that. Okay. One thing that may feel confusing is, and you don't have to know this in and out. We're going to hit this again later, but maybe this clears up some like kind of confusion. So when you allocate a worker, what that worker really is just processing power, right? A thread, or like a thread processing power from your CPU to perform work, okay, to execute a task. Every time you have something running on your computer, you're allocating, a thread or a processing power, to run the program. This may feel weird because you're running lots of programs on your computer, but actually what's occurring is back to the same. There's something called a thread pool, which is just like a worker pool, and you just have these various threads, and you don't, even though it feels like all your programs are running at the same time, really they're not running. We're not allocating a thread for exactly the same time. Really what happens is something like, well, Zoom needs some power, so we're going to allocate this guy to Zoom, and then we're done, and maybe Zoom needs to keep running, or Microsoft Word, so we allocate this thing to Microsoft Word. But now once we're done typing, this worker goes back in the pool and waits for the next task to occur. So that's really, that's the same exact idea. The way your computer is working is the way Prefect is organized as well, right? There's really not much difference, right? If you just want to recall the way Prefect is working, you're specifying, hey, I'm going to allocate or reserve kind of this many workers, and when there's a process to be run, we're going to allocate this, find a worker that's available, allocate him to do the work, and then when it's done, the worker goes back in the pool as somebody that's just available. Okay, and that's the architecture. So that's why what we need to do is allocate, actually have some process running, or at least made available to perform the work when it's the correct time. Okay. For you, all you need to do is just call prefect agent start -p default agent pool. What this is, if you go to, you can also see this in Prefect. Here's the work pool. Here's my default agency. Oh, here it is. And see that concurrency limit is unlimited, meaning we could have this pool, be assigned to maybe 3 different flows at once, and assign 3 different workers, right? That are separately, that each of which are working for a different flow. Okay, and you tells me here's how I start it, right? And then this is what it's. Let me see if I can see its work queue. So it's work queue. This is the default work queue, but this default work queue is getting my my work from the run. Sorry that all of these things work a little differently. So it's not, you don't have to go into, like, I don't know this inside and out, but this is essentially the architecture. Okay, so again, like, the way to think about this, now that you can kind of see it, is that we created this plan, this deployment. The deployment has various deployment runs, right? 1, 2, and 3. In terms of, these are just instructions to occur, right? At a scheduled time. In terms of actually processing them, we need a worker, right? So what we did was we created a work pool. This work pool has a queue of work that it needs to do, right? And this is getting assigned, from our deployment run. So this queue of work will occur, each deployment run will occur at the scheduled time. When it does, Prefect will assign a worker to the work and then execute it and then run that. If you don't have a work pool running, it's not going to have any workers to actually do the job. Okay? So that's why what you need is you need to run this line. All right? To assign a work pool. Cool. Let me see if there's other questions. Oh, okay. When would you opt for a cron job over? Okay, so Kyle's asking, when would you opt for a cron job over an orchestration tool? So one thing to say is, like, cron is a format for specifying when something should occur. So this you can pass through like a cron format, and you guys can ask ChatGPT or how to do that. It's just like a series of like stars and things like that. It's just the syntax is wild, but this thing can take cron, a cron format if you want. But when would you opt for a cron job? A cron job is fairly like ad hoc. It does not give you the scheduling benefit or the monitoring benefits of something like Prefect. It also doesn't give you kind of like the retries of something like Prefect. If it breaks, right, it breaks, and then that's kind of like it. Whereas with Prefect, if something breaks, then you still, that it's just that one task that broke, and then next it will still keep pulling. So yeah, you would use, all this to say, you would use Prefect over a cron job. A cron job is just very simple, like quick and dirty way to schedule something to occur that's built into your system with Bash. I've probably, like, I don't know if I've ever written a cron job. Like, I've probably only used an orchestration tool. In our index.py, we didn't specify which work pool the flow goes to. How does our agent know? Okay, so yeah, how do we know which work pool is going to be assigned? I think it's coming from the queue. I think it's coming because the queue, basically because there's only one, but essentially what's happening is there's a default queue, and that default queue is the task of this work pool. Okay, so you can specify different work pools if you want to. I mean, well, like, you don't have to, but you can just Google that. Then the next question, when do you need to create a custom worker? You don't create a custom worker. All you're doing is because the worker is just the guy who, the thread essentially, who is performing the work. All you're doing is creating creating the deployment, right, the plan, and you're specifying the work pool. I'm sure we can do that. Specify the work pool, and then the work pool will assign the worker that's available to then operate the task. Yeah, exactly. So David's saying, I believe the serve method takes a parameter called cron. Thank you. And it seems like David understands this better than me. You can say, hey, like, run this at this time, which means every day at 12:30. Okay. So you can use different interfaces for when to schedule this, but a cron job, like, you can schedule something just in Bash to run every day at 12:30. But again, like, you don't get that like logging capability. Remember, these logs are not just for you on your computer, but they're logged to Prefect Cloud. So basically, others in your organization can view this. All right. There are a lot more questions than I anticipated. Oh, go ahead, Kamal.
Yeah. As you mentioned that we need to be running this Python index.py and also the agent at the same time. My understanding would be the logs which would show up, that would be in the console for the agent, but I didn't see any, so I'm a bit confused.
Yeah, I don't know why. Like, it's just the way. I don't really have a good reason for it. Maybe I guess it's more like this is the deployment, and that I think maybe the way to think about it is a work pool can be assigned to multiple different deployments. Like, you could have multiple different flows, and each of those flows could be assigned to the same work pool. So I guess they're choosing to show the logs in each individual deployment, like under the deployment, and not the work pool. But I don't have a good. That's just my guess. All right. Sorry, we're not going like super in depth into it, or I actually don't know Prefect, like the underlying architecture super in depth, partially because there's many different tools like these. Like, we're doing Prefect, we'll also do Airflow, right? They all work fairly similarly in terms of their interface, and if you understand it to this degree, that's pretty good. Like, that's even probably like a level deeper than most people do. But then I think from there you can look through. The rest is really like looking through the documentation, and I think you'll be enough up to speed that you'll be able to understand that if you want to go. So what I have this movies data set, and you can see, if we take a look at it, each row we have like the title of the movie, the studio that produced it, right? There's the runtime, description, release date, and year. Okay, and we can do select star from movies. Now, let's say we want to do like a multi-level aggregation, right? Like, let's say we want to figure out for each year, what is the studio that had the largest or the highest average runtime. Okay. So first of all, like I said, this is a multi-level aggregation, meaning that we first need to figure out the highest, an average runtime per studio per year. Find average runtime per studio per year. And then from there, probably find the max, right? Max per year. Max average per year. Okay. So we're starting here, right? For each studio, what is the studio that had the highest average runtime? that means, right, these two steps. First, find the average runtime per studio per year. So it's like whatever DreamWorks 1992, Paramount or whatever 1992, DreamWorks 1993, Paramount 1993, and then find the max average runtime per year. So one thing that might just come directly in your head is like, well, we can just use a subquery for this, and that's true. You can just use a subquery for this. Just in terms of the syntax, CTEs are easier, and then as you'll see, it's like you can repeatedly reference the same CTE. So I personally prefer CTEs. So let's just see how we can. What is a CTE? CTE, it stands for Common Table Expression, but that name, I don't even know what that name means. What we need to do is to create a CTE. All you do is put the word with, and now we can call this. Let's do this. Let's first write the query. So we'll say select. The first step is find the average runtime per studio per year. So do select average runtime from movies, and then we'll just do group by the studio, comma, year. Okay? And that's giving us the average runtime. Let's say as average runtime. Just give that column a name. And then we'll also, give us the studio, the year, and the average runtime. Okay, so select studio, year, average runtime as this thing as the average runtime from movies, and then just grouping by both columns. So that means that we'll get for each year, for each studio in that year, we get a separate row, right? Right, so that's why S, whatever that is showing up both in 1974 and 1979. So the next thing now to integrate a CTE, all you do is you just use the word with, and then you give this query, the result of this query, a name. So we can call this average studio runtimes as, and then put parentheses. All right, and these parentheses will hold like the body of the CTE. And now if you just run this, this will break. Okay, you always need to end with a select statement. So we'll do select all from this. And we should get exactly the same result. Okay, so let's just take a look at this again. All we're doing essentially is we're just giving this query a name and storing it essentially like in a temporary table. So you're essentially storing the results to a variable, and then you get to reference that variable. So with, we're going to call our table the average studio runtimes as, and then here we put in our select statement, right? So this is where we group by the studio year, calculate the average. Now what are we doing? We're selecting all the columns from this table. Meaning, if we want to, like we could reference this named column, right? We could just select average runtime from there. Other things that we can, let's go back. We'll do studio, year, average runtime. And now maybe the next thing we'll do is get the max runtime per year, right? So it's the max of the average of each studio. I don't think I can do studio anymore probably, but I'll do the year, get the max, average, and then what I want to group by the year. So for each year, what is the max average runtime? Okay, and let's give this thing a name too, as highest average runtime. And you can see, like here's, right, the 1914 had a studio that had an average runtime of 181. Here the highest one was 192, etc. So this is a CTE. All you're doing is you're just wrapping this in parentheses, wrapping your query in parentheses, giving it a name, and then selecting from it. One thing to note is that you can have CTEs like all the way down. So we can do comma, and then let's say we want to do the highest total, I guess, like the highest runtime across all these rows. So it'll be comma, I'll just call this like highest runtime results. And then same thing as parentheses. And now I just do the same thing. I'll move this to here. So I'm going to call these results highest runtime results. And then I'll say like, select max of this column, highest runtime average from highest runtime results. And I guess this was the largest one. Okay. I probably should be able to do year too. Yeah, and the year was 1974. All right, so notice with the first one, you use the word with. With every one afterwards, it's just a comma. It's just with average studio runtimes as, here's my select statement. Now in the next one, I'm selecting from this previous one, and I'm calling this something, but to call it something, I don't need to use the word with. In fact, it will break if I put the word with in here. Okay? So you need to, it's just comma, the name, and then as parentheses again, and then again you end with a select statement. All right, so these are CTEs. We're covering them now because soon we'll get into DBT, and they are used all over the place in DBT. So you'll certainly get used to them. How does this feel? Conceptually, good, because it should feel just like they are, just like subqueries. I think they're easier because you can just kind of like read it sequentially. First get the average studio runtimes. How do I do that? Then get this. Cool. These are so much easier than subqueries. I'm glad we feel that way. All right. We can talk a little bit about project stuff. So you don't have to start working on projects yet, but if you have time, it's worth, if you finish your labs early, it's worth thinking about. So I did put, in the reading, right, some like kind of good tools, some good like resources to look at projects, right? It's like these kind of like industry reports. That pudding.cool website I think is really good at finding interesting things. A couple things. One initial thing to mention is like, and I know I said this earlier, but if you are working for a company that uses data, and it'll be great if you can create a project for them. This is not like meaning employers will value this much more than a personal project, and that is totally fine for our class for you to start working on a project for your company. Some like kind of complications, like the reason I know it's not easy. Typical things that come up when trying to do this are like, well, there is no work really for me to do. Maybe there's no data engineering team for me to work with, right? Like, or there are obviously a separate team than what I do now. So there are a couple of things I'd like to point out. One is, like you can create. I'm not saying like, your mileage may vary, but for a lot of students, you may be able to create or like / brainstorm, a potential data engineering project. And what I mean is, this may be something that no one is really asking for, but that you're doing essentially to show that you have this experience. So let me just give you an example. So one of my past, students, just from, she actually recently got a job like 3 weeks ago. She was a data analyst for Colorado State, and built lots of dashboards, wrote SQL queries, things like that. But she never built professionally a data pipeline, only through the internship. So I asked her to start building a data pipeline for her employer, and that really helps because then not only do you get to put this on your resume, but in interviews she's frequently asked, have you built data pipelines? Have you done this, professionally, right? This is part of the reason why we do the externship. But then if you're able to do this on your, in your job, that's even better, right? So even if no one was asking for this, even if, it kind of was just to put on your resume, it's still, you still, one, get the skill set, and then two, get to say that it's in production, people are using it, and, provides a real benefit. And it doesn't have to be, in her case, she was able to build an end-to-end data pipeline, and she used, Prefect and AWS and things like that. But really, the more that you're able to have your skills line up with the job that you're looking for, that's really what we're trying to do. So that means, like, if you're able to do, like, any kind of cloud computing, right, or try to move into that. If you're able to, obviously any additional Python / SQL work, right, the more of that you can do, the better. Any of the tooling, like we'll get into Docker and Terraform, things like that. Even things that we haven't kind of learned yet, I'm happy to, release some curriculum early if there's opportunities for you to integrate this into your work. And then finally, like, you think about just like building a dashboard, right? Either using like Streamlit or Tableau, right? Or just like more analytics type work. Any of that is fine, any of that will be helpful because these jobs take on different flavors. And like I said, like if you want to, even if no one's asking for it, if you're able to, do this on your own time for the company, and really like you're free to use any time we allocate for the projects to do this kind of work, that's great. Like that will be really nice. And then the other thing is, if you have a manager, you can tell them, just say, hey, I'm taking this data engineering class. We're learning, various analytics skills as well as data pipeline skills. Do you think I would be able to get more into this work, right? Like, or do you think I could do this potential project? Like I said, it doesn't have to be the entire tech stack exactly. Even any piece of this that kind of lines up with your job, like that's great, because the more that you can just kind of make the argument that you've already done this thing that you're now applying for the job, that's really helpful, right? It shows kind of that transition, and employers really respect it. So that's kind of the first thing. And I'm happy also to, speak with, kind of brainstorm with you, because I think sometimes it is just hard to think about, like, how do I provide something of value in my current place, and how do I do that when it's not exactly what I'm asked to do currently? So just take some degree of creativity. Now, but in general, if that doesn't work, or just obviously if you're not working, then, in terms of good projects, right, we said there's kind of like these good, topics. And also, like, don't do, we also mentioned some topics that are not good, right? Like, like anything that's kind of like feels more like toy, like some people like have used like the Pokemon or like some sort of game kind of like API, not of like the gaming industry, but just like of different Pokemon characters or things like that. That stuff's fun, but it's not. It's hard. It's going to be hard for an employer to think about how that relates. So something more related to like something businessy, or solving like a real world problem is what I recommend. It's also going to be easier for you to network, right? Like kind of with these types of topics than something that's that's fun. It's hard to find, like, people don't put that on their LinkedIn as much, like those types of other interests. So these types of things, and then think about data sets. Like, it's going to be because we're doing something with orchestration. Oftentimes, right? We just learned about Prefect. You want data sets or APIs really that update. So like static data sets are okay for maybe a part of it, but you want to try to think of like an API or a data set that is going to update, maybe once a week, once a month, once a day, right? Something like that. That way you have a reason to perform scheduling, and that way you have to account for those problems that we saw of like, okay, I want to make sure I'm not pulling, the same data each day, that I'm not loading the same data into my database each day, right? But I'm doing this repeated process using Prefect to then load data into the database. So that's another thing. And then you can also just think about when it comes to like the dashboard or a visualization, just think about like what insights, what questions are we trying to answer for people, Because sometimes I'll see visualizations as like, visualize showing kind of showing a chart that maybe looks okay, but we want to be able to like answer a question with it, right? So that gets back to our, what we talked about earlier, in terms of data storytelling. But it's like, what's the overall question, right, that we're trying to really answer about this? Like, so for example, with the with like my favorite data set, the Texas drink receipts API, I can think of like many different questions. I mean, because this is really like a great way to get at like revenue for a company. So it's like, how is revenue changing based on whatever time, right, across a restaurant, based on the reviews, based on, et cetera, et cetera. It could be like post-COVID, which restaurants recovered and which ones didn't. How does the amount of drinks, does it really correlate to revenue? So you can imagine pulling data from like public companies and seeing the average drinks sold at Chipotle, and then seeing how that correlates to their quarterly revenue, right? So things like that are interesting, but you want to think like, how would people use this? Other things. One other thing I wanted to mention was, here you're pulling data from an API or a data set. Eventually, if maybe you pull data from multiple data sets, kind of like I'm giving the example here, right? We use the drink receipts API for, getting that information. Maybe I use the Yahoo Finance API for getting their stock or their revenue information per quarter, right? And then I try to do a scatter plot of the two. Okay, you don't have to. You can start with just one. That's fine. But as a way eventually to make it more complicated, right? I'll try to give like a week, at least. We'll see. But I'll try to give like a week to work on projects. Like I said, you don't have to do it yet, but it's good to start thinking about and like researching and exploring, and then choosing something that you're interested in, and also that either corresponds to your previous job, or maybe something that you want to move into. Questions about this stuff, about, I don't know, any of the project things? For right now, it's fine for you to start with either, thinking about some kind of questions to answer. So the analytics stuff that we talked about. And remember, like, we saw about quickly exploring a data set and doing dashboards. You don't have to move on to Streamlit. I'm just like Plotly or Pandas is fine. And then in orchestration, right? Just like these two tools, right? And really with orchestration, just start with Python. Just start with like pulling the data from an API and save it to a database, right? Like that's a fine place to start at this point. Questions? You guys feel all right about that? Is just start with a single table maybe, and just get down some of the information, right? If like I have a flight, it's like, well, who's flying it? So maybe we have like a pilot ID. You could think maybe there's like a co-pilot ID potentially too. Or just, yeah, that's fine. Co-pilot ID. And that might also point to the same pilots table. And then we have a plane ID, takeoff time, landing time. So if you just think about like a starting point, it's like we're starting about our transaction, right, table essentially. Like where do these different things come together in an event, right? Which is like our flight is an event. And it's like, and then you maybe go through the checklist, like who, right, what, when. And as I go through the checklist, right, we're forgetting where. So probably origin, probably airport, and then and that probably will have an ID, and then destination, airport, ID. Okay, and then from here you can start kind of filling things in, right? So this means obviously we'll need like a pilot's table. That's easy. First name, last name, ID. We'll need like probably a planes table, which just has like the ID, maybe has like the model, and like a model. You might think then, like if you wanted to, you could have like a plane models table, which maybe has like the number of seats, the I don't know, some other kind of specifications of it, the fuel type or something like that. This is a little extra. Maybe in terms of the plane, maybe you also want, like the year, right? In terms of like the individual plane, right? So then maybe we'd have a model ID here, just to point to the fact that there's another table that probably captures the plane models. So we have pilots, things that start getting interesting. So we have the plane, who, what. This is kind of interesting, right? Because you want to start thinking about things that repeat in your table. So like in origin and destination, those are going to repeat, right? Again and again, right? Like you see it advertised, Southwest flies from this city to this city. So that tells me there's another entity. If you start seeing, and by repeat, I mean, if you write out like the rows and there's like New York to Chicago once, and then New York to Chicago, right? And it's like really probably it flies to like the same airport too, in between them. So this repetition tells you that, like in the fact of across columns, tells you that really there's another column, there's another table here, and also just like the physical world does too, and that's like a route, probably routes, which is the origin city and the destination city. Or not city, airport. Right? Because if you just do city, we know that there are multiple airports in a lot of cities. So, and then this is the destination, airport. And now we would remove it from here, right? So now we would replace this with like the route ID. One thing that a student pointed out to me is, well, like, actually, like, probably it's not like the timing of the flights is also repeated, so you might say like the takeoff time and landing time, there's probably like a schedule or where these flights happen, like this route happens at a specific time, like planned time, planned takeoff and planned landing. And then so now we again kind of replace scheduled or route ID with the scheduled ID. And this is like, oh yeah, this is the flight, the 9:37 flight out of New York to Chicago, right? And then probably maybe you'd do this and you'd still have the date. Or maybe I forget, I don't know what I would call this. Maybe I'd call this like planned. But I want to get the idea that this is like repeated. Okay? And now, the reason why I pushed against having, I was thinking, so let's say we'd have a planned ID. Just notice that there's a difference between when we plan to take off and when we actually take off, right? Right, like kind of the information we track varies. Like initially, the flight hasn't happened yet. We're going to take off at 7:30 a.m. But then once it comes time for it, right, it's actually 8:30. And so now we need to, there's a couple ways of tracking this. Either we could track the official takeoff time and the official landing time, and how that differs, and we could just subtract, just kind of see our delays. Or what we could do is create a separate table for delays. We don't want to track this information twice. So if we have both, that's a repeat. But, we could do one or the other. We could create a delays table, or we could just look at the difference between the planned takeoff and landing and the actual, right? If you think about what you'd want to track with delays, if you're like in an airport or a flight, like Delta or something, you probably want to track like why it was delayed too. So if I do that here, like delay reason, I don't know. I don't love it because it's kind of a code smell if you start seeing certain columns are filled sometimes and not filled other times, right? Like this delay reason only occurs when this thing differs. And like I also don't like the idea that we have to look to this other table to kind of determine whether or not this should have something or not, you know? So I probably would have a delays. Exactly. So I probably would have a separate delays table, right? And now this would move away because we'd have it in our delays table. And this would have, the flight ID. And this would have, what should be up here. And then this would have the delay amount, or delay time. And maybe we'd have like a delay reason. And probably, again, what do we want to track? There's probably common reasons, like repeated reasons, right? Like they didn't get the fuel, or there was some sort of equipment issue, or the pilot was delayed for whatever reason. So this would probably be like delay reason ID, and then some sort of description, and then meaning that we would have a delay reason table or some sort of equivalent, and that would have our text, and then that's probably just it in the ID. Okay, it could have a category. Like this could have a category, and then we'd have even another table. Other things we're missing. One thing to note is, again, like there's this difference between, if you're an airline, probably between like what's planned and what actually occurs. So for example, you may have, like this is the actual plane, this is the actual team, but what was like the scheduled plane, right? Like before the plane takes off, you're going to probably have an assigned plane and then always have the opportunity to switch it out for whatever reason, but you want to track that, I'm guessing. So again, flight ID, plane ID, and then the same thing with the actual pilot, scheduled pilot. I would say pilot. And then flight ID, pilot ID. And then maybe we'd have something of like co-pilot, which is like a Boolean. I don't know. Like whether or not, or like primary pilot. Not sure. But the idea is like you want to think of, normally when you sketch this stuff out as like a toy, like a project or whatever, maybe you just have like 3 or 4 tables. But when you do something like this in production, or like think about it for like, if you're really doing this, for an actual company, you're going to have all these other little tables. And, like in an interview or in a project or whatever, for your internship, it's not overkill to raise this and to like write this out. Like people want to see, like a big thing, people are trying to see like, are you kind of a pro or not? So the fact that you're just taking this stuff seriously and like not being like, it might be too much work. Well, not really, like we want to track this information, and like this information, if we don't track it, it's just gone. So it is, this data is really valuable, and it's not too much work to capture it. Okay, with route ID and plan takeoff, well, we don't need. Okay, so the question is for delays. Right, this is for the delays table. If we need route ID and plan takeoff as a primary key, once we have the flight ID, then I can get to the route ID and the plan takeoff. So that part is good. So that's another thing, like a good check is just to see like, can you get to each piece of information? And typically only once, right? Like if I want to find out who the pilot is, okay, I go here. Co-pilot, I would go here. You could argue for breaking this out into a separate table, like a flight has many pilots. It's possible. This seems like it's just in one place. Again, in terms of when does the plane take off, that we can figure out from the planned takeoff plus the delay time. There may be an issue here. I was thinking there could be delays in the middle of the flight. Like there could be pre-flight, pre-takeoff issue, and then there could be during, right? You get rerouted or something like that. So I don't know. Maybe this gets restructured. It's worth maybe thinking about that more. Okay, flight to route. Can we get there? Here's the origin airport ID, and then the route actually comes from planned. So you only get this from one path, right? We wouldn't want to have it here, right? This would be wrong if you have route ID here, because now I can find the route both by going to this table, flight to here, and then I can also find it now by just tracking it, right? This planned route ID has a reference here. So you do want to check that, like if you're doing an interview or doing this for a company, to make sure there's only one way to get to each piece of information. The plane ID, right? Same thing. We wouldn't want to have a model ID here, because now we can get to that information both from the plane and from directly from here. Okay. We can see what did I actually do. It's pretty close. I obviously looked at it beforehand, but pilot, I called this assignment. The pilot assignment, the plane assignment, the flight. Yeah, this is the origin airport. That's a mistake. I should have deleted that because we're getting it from and we need a route ID here, I think. Yeah, so I like the one I have now actually better. I think there's less errors. I can I don't know if I can share. I can take a screenshot of this and send it to you. And again, you might have other things. I do think that the delays we need that is the main thing I would think through more. But these are good types of assignments. I have been asked a question like this before in an interview, and I found it totally valid. And this is all. By the way, this is a question I always ask in interviews. Not this exact one, but I always ask a data modeling question, because for me, it's it shows object-oriented design, or a sense of object-oriented design. It shows obviously understanding third normal form, which if you're working with data, you should understand. It shows business sense, right? Thinking through the domain and how it translates into code. And then these types of decisions just have an enormous impact on the rest of the application. If you think about how our API is designed, well, our routes probably mimic our tables, and all of our queries are going to be determined by this, and all of our classes. This also just has a very strong impact on how you design an application, and it's costly to redesign it. Even though that's always going to happen, but you want to try to reduce it. I don't know, questions about this or things to potentially add to this? Okay. The only stuff left is really readings and then DBT. So, in terms of the readings, what we've been modeling so far are transactional databases, meaning this data modeling is designed for applications that get lots of inserts and updates to the records. And what is a transactional database? It backs a website, any website, Twitter, whatever. It could be your project website, just anything that a customer will be touching. Okay, one thing that you'll notice, right, as I say, typically with transactional databases, because we're following this rule of third normal form, you're going to see a small number of columns, meaning 5 to 7 or fewer. And you'll notice that was true here, right? Basically every table here has 5 or fewer columns. If you follow third normal form, that would just naturally occur. It encourages lots of tables, but small number of columns in each one. And that also helps for a transactional database, because in a transactional database, you're creating lots of rows lots of times. And if you're keeping your columns to 5, then the update and the inserts are small because there's only 5 entries to change each time. As opposed to, as was with analytical, it encourages longer tables. So keeping this small is good. As we said, like one single source of truth. Just remember why we say there should only be one source of truth. And by that, I mean, we made sure there was only one way to get to each piece of information, right? Like we weren't both doing a takeoff time and delays, because then we'd have the same information stored in 2 different places. So why do we make sure there's only one source of truth? It's because it's bug prone to not have that, right? If we as you make a change to your code base, you're going to have to make sure that you change both what's stored in like the flight takeoff time and what's stored in the delays, right? To make sure that they're both in sync. So it leads to like duplicating code lots of times, and it leads to bugs oftentimes, because as a developer, you're like, I changed it once, it should work. Not that I now have to find the bug in multiple places. Other things, let me see. Now, so OLTP, right, third normal form, emphasizes just single source of truth. Oh, and this is the other thing we talk about is, right, tightly coupled information, meaning, remember, this is a way that you can check that your table is in third normal form. Every non-key attribute must provide a fact about the key, the whole key, and nothing but the key. What does that mean? So here we have non-key attributes, right? Like this is, and if you look at the first name, the last name, that's providing a fact about the primary key. This is some metadata, so we'll let that slide. But you can see like first name, last name provides information about one entity, right? Like the actors table. If you go to our flights thing, you can kind of see it, right? First name, last name about our pilot, number of seats, fuel type, right? About a plane model. None of the flight, these are not, you can say like, well, is the pilot about the, like it is, these things all are about the flight, but also notice these are not these are all key attributes, right? These are foreign keys. So it would be wrong to have like, and I think you all know this, to have like pilot first name, right? That's wrong, because that's a non-key attribute. It's not a foreign key, it's not a primary key, and it doesn't point to about the flight. Okay. Right, if it says name, another trick, like another kind of smell, is the fact that you have to prepend this with the word pilot means that it's not about the flight. Because otherwise you should just be able to say name, the name of the flight, right? Like that, if you say name and you think, and it means name of the flight, that's fine. But if you say like pilot name, that descriptor, it should be a smell that you're violating third normal form. Okay, so whenever we have an online transactional processing database, it's not about the database. It's more about like the way we do the data modeling, and we're doing that to back like a website, meaning something that's consumer facing. Okay, you want to follow these rules and we'll get these benefits, right? Meaning that our tables will be small, so that this is good for like lots of quick inserts and updates. We'll have a single source of truth, which is good because our code base is going to be quite large, and if we don't do that, we're going to have duplicated code and duplicated information, and we want tightly coupled information, right? And following this one rule will really get us to a lot of the other things. Okay, so then an analytical database, actually we should go here. Say you have this data, right, like just this, like an e-commerce website, and this is obvious. The database that backs this would be an OLTP database because it's consumer facing. As like an internal analytics team, you want to collect information both from your transactional database. So we're going to have to migrate our data from the transactional database into a separate database, like what we'll call an analytical database. So I have to migrate that data. And, as I said, it's a lot of data. So this was, these were all the tables for Shopify, for like a typical Shopify store. You can take a look at that. But then also you'll want additional data, meaning, things that might not be stored inside like a database backing this website is like click information, meaning, people might be tracking who clicks on the website but does not actually buy something from the website or does not actually sign up for the website, right? And then if a person comes back, we can, because of cookies, figure out that the person came back. So every kind of event on the website, that might be information that you want to track in an analytical database. Then we want to track, the sales information, like someone who then calls our store, or maybe they start to put in their email, but then they don't actually register, right? Like we want to track that information too. We may want to track third-party information, meaning, we're tracking that this was like $58 for this top. How much are the tops of our like competitors, right? So we might need to scrape or pull down third-party information and want to store that in an analytical database. So the point is, there's a set of information that we want, that our analytical team and internally we want to track, that our consumers or customers don't need anything to know about. That is not going to affect the performance of our customer-facing application, but is something that we as a company want. And that's information that we'll store in an analytical database. So how we do that and how we structure it changes as well. And there's a flux, like OLTP structure, third normal form. That's one extreme. That's kind of what I have here. And then the star schema is another extreme. And the truth is, many companies, for the analytical purposes, are in between. Okay? The most important thing for you to know is always the stuff in the beginning of the course. So that's the OLTP structure. However, you tend to relax these rules in an analytical database. So why do you do that? Well, you can see that following this OLTP structure encourages lots of small tables, but there's lots of them, So, for example, right, this was for like a film rental, like movie rentals, and you can see like a store has like a manager ID, and then that manager ID, we need a separate table to like store his address, and then we need, once he has a zip code, we need a separate table for that, and then we need a separate table for the city, and then we need a separate table for state. What's the problem with this? This leads to lots of joins, right? Just to figure out where the manager lives, like what state does he live in, we have to go through join 5 different tables. So not only is that, it's fine for a developer probably, but if you're like a product analyst, or you're more like, if you're just someone who's not very technical, doing all those joins can be annoying. And then 2, they can be costly, meaning it can just take a lot of time to do all those joins. And if because of the way of joins work, they are time consuming. So that's just another thing to consider. So what you tend to do in an analytical database is you can kind of relax our rules about single source of truth. So notice here's my customers table. We have first name, last name, address, and then we have zip code, city, state. Even though this stuff repeats, right? City and state. So we wouldn't typically have this if we were following strictly OLTP. In an analytical database, we kind of say it's okay. Because it allows us to answer the question of like, where does our customer live? Like right away, Same thing for, this stores thing. We shouldn't have manager first name, manager last name, right? You can see the code smell. The fact that I'm prepending it with the word manager means it's something else. But we're relaxing it because it's like, all right, I know kind of the information I'm asking questions of about a store. Just tell me who the manager is. So you kind of do that. And then here in dates, we're actually expanding information. All of this information about the date that a rental occurred could be answered just with one column, right? The date time column. But instead we have like date, year, quarter, month, day, week, is weekend, all broken out. Why else do we do things like that? Like for thinking about this, now it makes analytical queries easier. For example, something like how much revenue did we bring in each day, each year, each quarter. All we need to do is join the sales table to the dates table, and then group by the quarter, month, day, week, blah, blah, right? And do a summation here. So it makes these analytical queries easier. So typically, the way that you structure this is you have what's called the fact table in the center, and then each of these are dimension tables. So with the fact table, this is again like the transaction. It's like the coming. Where do all these different entities come together in a purchase, right? In a sale. So this is our transaction, and then that fact table will generally just have foreign keys and a target, meaning what are we trying to predict. It could have more than one, like it could have the price and the cost, so way you can find profitability or something like that. But everything here is a number, okay? And in the dimension table, you'll find more like soft information, text information. And basically these dimensions are answering those same questions: who, what, where, why, or not why, but when, right? So this is when, obviously. This is where is the stores. This is who. This is what, right? And again, a benefit of this is for analytical queries, you can now do these same group buys, find the price that this particular movie brought in, you know? Just select all from sales, join the movies, group by the title. If I want to see average, price per length of movie, right, same type of thing. So everything's just one step away from our fact table. And by doing these group buys, which is a lot of what we want to do with analytical queries, we can write these fairly easily. Okay. I think that's mainly it. Talk a little bit more. Okay, have I reached out, for instance, like the airline database design? Have I conducted my own? Well, I've been involved in like designing, like professional databases. So I haven't designed airline databases. Like I designed databases for like states, but they're very complicated. You're working with like a million lines of code, hundreds of tables. So that's just something to do that. How challenging is it to redesign a database to add more tables to a data warehouse? Well, those are two different things. Like an OLTP, and it depends. It's actually, in my experience, it's more complicated. It's probably more complicated to redesign a transactional database because there's just more and more code that sits on top of it. Right? If you think about all your Python code that's querying the transactional database underneath, and then all the front end that's then relying on the data modeling of the Python, right? Like it's like this is the foundation, is essentially your database. So, and the tables in it. So changing it, like changing even a column, can take like a lot of work, meaning a couple weeks worth of work of a couple individuals, like maybe 2 to 4 individuals. Which may not seem like a long time, but that's a substantial refactoring. Sometimes it could take months, depending on the impact of it. But yeah, I don't know. But you're always following these rules, and sometimes you're relaxing them. It still has impact, obviously, in an analytical database as well, but it's your SQL queries that are going to be changed. So one other thing to note, I guess why we're covering this now and why this is kind of like a prelude to DBT is, what you can think about is the fact that, okay, we have our transactional database, which backs, a website, right? Somebody visits on the browser and, has this code base, and we can have like our Flask app. And then, so we're going to take this data, and you can, there are different techniques. Like you could literally just like use a tool like Fivetran, which it's just a very easy like plug and play. You just put in your database credentials, and it will copy over the data to your analytical database. So we take the data from our OLTP into our OLAP database. OLAP. Sorry about that. as well as data right from our third-party tools, meaning, like HubSpot. You can migrate that data in, and maybe we'll move in data from like Mixpanel and things like that, right? And like I said, like kind of third-party data, like like how our competitors are doing or something like that. And how would we do something like that? Again, there are different tools at the very least, but one way you all know how to do this is Prefect and working with APIs and loading the data to a database, right? So like certainly like building a scraper to track prices and creating, tracking that here, that all works. Like that's a good practice. You also would want to move in, um, your transactional database. How can you do that? You can also do that with Prefect, but as I said, there are off-the-shelf tools, meaning people have just built built software that makes it like kind of like one click to take your data from from your transactional database and move it into an analytical database. Then from there, this data, because we're taking our transactional database data, this data is going to start off right in third normal form. But what we're going to want to do is coerce it through like a series of CTEs really into be in this more of this data mart structure that we saw. Okay. Not only are we going to want to do that, but we're also going to want to say like, oh, this customer, that I saw in my transactional database, that's the same customer that I saw in HubSpot that my sales team spoke to. Or that this is a customer that showed up in HubSpot, but then, never actually purchased from me again, right? That's very useful because then we can start to know like who are, both like how's my sales team doing, but then also like who are valuable customers and not, and who should we assign them to, et cetera, right? Like what are the flows that led to a purchase? Are these, again, types of customers that we really care about in the sales funnel? How is, data from my OLTP, what are my prices looking like? How do they correspond to third-party competitors, their prices? Okay, so we're going to want, and we want to make sure that we're matching up, right? The product type, and that we're comparing apples to apples. So, right, like we're not only going to have a problem of, transforming the data from like this OLTP structure to this data mart structure, but then also we're going to have issues of what's called, one, cleaning the data, so that'll be staging. We'll just say cleaning for now. And then two, combining the data, and that'll be integration, meaning we need to combine, say that this customer from HubSpot matches with my customer from my OLTP. And then three, like actually coerce, moving to the mart stage. So we'll see this in DBT that, we're like I jumped a little bit ahead by talking about this, but we'll see this that like the work of DBT is a work of really like doing, cleaning all of our data, combining it, and transforming it to move it into this data mart structure. Okay, we have a couple questions. Oh, thank you, Miles. I normally get complaints. So thank you for complimenting my drawing skills. Cool. All right, so, that's basically, the readings cover the same thing, like OTP versus OLAP. This stuff